I am Joe Masilotti, and today I'm going to talk about Hotwire Native. But first, I got to say something. We're freaking spoiled. Rails developers are spoiled. It has never been easier to build, iterate, and launch with Rails than it has been today. Even complex UX interactions are possible without writing any JavaScript, thanks to Hotwire on the web, and Stimulus, and Turbo.js. Our feedback loops are lightning fast. Sometimes we can go just minutes from deploying to seeing our code live in production, sometimes seconds. And the best part is that we can ship whatever we want. There's no gatekeepers. There's no permission needed. It truly is the open web. But when it comes to mobile, specifically mobile apps, suddenly the rules change. We have new languages to learn, new toolkits to master, App Store rules to abide by. All of a sudden, we've lost control, and we're playing by someone else's rules, Apple or Google or both. What felt effortless on the web suddenly feels impossible on mobile. But we can't avoid mobile apps anymore. Almost all time spent on mobile devices is spent in apps. 92% versus the 8% in a browser. Mobile apps aren't a nice-to-have anymore. For many products and industries, it's the expectation. Said another way, users live in apps. And getting there, getting to try it in the first place, well, the App Store and Google Play, they have their own advantages. How many times has this happened to you? You're coding away on your laptop, someone walks up and says, "Hey, how do I try that app you're building?" And you roll your eyes and say, "Oh, you visit my website. It's easy." And they pull out their phone, and they search for your app in the App Store. You just lost a moment there. When someone hears about your product, their first instinct is not to type a URL into the browser. They go to the App Store or they go to Google Play and they search. And if you're not there, you've just lost a potential customer. Outside of discoverability, there are a bunch of things that mobile apps can do that web cannot. Reliable and customizable push notifications, like interactive buttons or dynamic content that updates after the push notification has been sent. Interactions with Bluetooth and NFC. Pairing with a smart scale or a blood pressure cuff, a heart rate monitor. Controlling nearby IoT devices, like lights or speakers. And NFC, near-field communication, tapping a badge at a conference to check into a session, or scanning a product tag and getting instant details on it on your phone or rewards. Integrations with Google Fit and Apple Health, logging a workout, syncing steps, tracking heart rate, logging calories, reading calories. There's no API accessible for the web for these things. And not to mention the real data on the device, the user's calendar, contacts, and wallet. Deep integrations with these are possible with mobile apps. Automatically blocking off time in someone's calendar when they register for a conference session. Inviting all your friends from your address book by the ones you select, and not dealing with a clunky URL to share. Or loyalty cards that show up on your lock screen when you physically enter a store. Mobile has a lot of advantages, mobile apps. So let's say that at this point, 6 minutes in, I've convinced you. You're ready to build a mobile app, right? Let's go. So first, we have to learn Swift, the programming language for iOS apps. Then we have to learn Kotlin, of course, for Android. Then we want to get something on the screen, so we have to learn Swift UI for iOS, Jetpack Compose on Android. Once we have stuff on the screen, we want to make sure we know it works with iOS 18 and one step back with iOS 17, iOS 26 in a few days. Like 7 versions of Android because of the fragmentation. And then we have it built. We're ready to go. We want to share it with our users. Well, now we need to get it into the App Store and Google Play. And this is just the front end. We haven't even talked about getting the data from our server into those apps. So on the web, we know this, right? Getting data to the device, the browser, we have a model. That sends some data to the controller, maybe through an IVAR. Sends data to the view through an IVAR. Maybe you're using ERB. And that renders out some HTML. Easy. But for mobile apps, we need this in place, and then we also need another layer. We need an API-specific controller to massage our data from the model to get it to work in our JSON view. From there, we send the JSON over the wire to iOS, where we render out our screen in Swift UI, and then to Android, where we render out our screen in Jetpack Compose. And I've skipped all the networking. We've duplicated our work, and we've left the Rails ecosystem. We now have twice as much, if not 3 times as much, business logic to maintain. And every new feature requires building it for the web, iOS, and Android 3 times. When something breaks, 3 times the debugging. For small teams, let alone solo developers, this is a maintenance nightmare. It's not possible. It makes native apps feel impossible for Rails developers. Now I know there's someone out there going, Joe, PWAs. Of course. Sadly, PWAs fall short in a number of categories. Outside of our circle and our community and the developer community at large, very few folks actually install PWAs. And the native features that are given to those that are blessed by Apple and Google are often hamstrung or unreliable. Push notifications that just stop working, or getting signed out of your PWA for no apparent reason. It's not unheard of for Apple to clear cookies under the hood and give you no warning from a PWA. Are they doing it on purpose? Do they get 30% from the App Store? Maybe. And of course, PWAs lack App Store discoverability, but also create an even bigger burden. Not only do you have to get them to your website, you have to tell them how to hit that share button at the bottom and then scroll down to add to home screen, which doesn't sound anything like add app. It sounds like adding shortcut. Have you ever watched someone over their shoulder as they tried to do that? Someone who isn't tech savvy? Don't. Okay, so if fully native is over here, and a PWA is over here, what's in the middle? React Native. React Native has some benefits. You get to share your native code between iOS and Android. So no longer are you building things 3 times, you're building things twice. Once for web, once for native. You still need all of the, JSON endpoints and stuff, so you're duplicating logic there, sure. If you have React.js on the front end, React Native is a good choice. Do not use Hotwire Native if you're already using React on the front end. It won't give you much benefit. But if you're using HTML over the server and even Hotwire on the web, React Native is just forcing you out of the Rails ecosystem and into the JavaScript one. We want to We want to build mobile apps the same way we build Rails apps. Is that so much to ask? We want to ship instantly. We want to deploy the same way we deploy on the web and have our changes go live across all of our platforms and devices: iOS, Android, and web, desktop, and mobile. We want to own our release cycle and not be delayed by the black box that is App Store review. We want to keep building with Rails. We already found the tools we know and love. Let's keep doing it. We don't want to become mobile experts. We don't want to hire teams of mobile experts. We want to build mobile apps the Rails way. But how? Anyone know? Of course, Hotwire Native. Hotwire Native gives us access to all of this and makes it accessible to Rails developers for the first time. Hotwire Native changes the way we think about mobile development. It means that mobile apps are no longer off-limits to Rails developers. It means that even solo developers or small, tiny teams can achieve feature parity across web, iOS, and Android. So what is it? It's just a web view. That's it. It's just a web view. It's a web view with a little bit of magic around the edges. But that magic does a lot. Because it's rendering the same HTML and CSS that we're using on our server, we don't have to duplicate business logic. We can just send that same stuff over the wire to our web apps that we're sending to the mobile apps. Since we're deploying from our server, we get the same stack that we're used to and the same infrastructure where we push our code and it goes live in production. Now just not on the web, but also in our apps. And if we isolate our changes to Rails, we actually can skip App Store review. Yes, we'll have to go through an initial round to get our app in the app stores, but after that, as long as we don't touch the native code, we can continue to ship features and bug fixes that go live immediately without Apple or Google knowing or caring, and without breaking the rules. But most importantly, we get to keep building with Rails. We're not splitting our attention, we're not hiring new mobile experts, and we're doing it in a way that makes it maintainable for small teams. So, why am I up on stage today? Some of you may know me as the Hotwire Native guy. I've been building hybrid apps for 10 years now, with many variations of Hotwire Native, which we'll talk about in a sec. And I'm here to help you take your Rails app from the browser to the App Store. I've shipped 25 of these to production in Google Play and the App Store. I'm also one of the maintainers of the Hotwire Native library. This QR code is to my blog, where I talk about Hotwire Native weekly and have a weekly newsletter to level up your skills with free tutorials and such. Also, I wrote the book, which we'll talk about later. So let's see how Hotwire Native actually works. We know it's a web view, we know we have magic, but let's pull back the covers and see what's going on under the hood. We have our Rails server, and we have our browser, our mobile web browser. Think of this as Safari or Chrome on your iOS or Android device. And we send, well, HTML over the wire, Hotwire. On a mobile app, we have our navigation bar up at the top, and we have our tab bar down at the bottom. But what's in the middle? Well, it's the same thing. Instead of a full web browser, it's an embedded web view, which means that we can send the exact same HTML that we're sending to the mobile web clients to our apps. If you take away one thing from this talk, it's this. That HTML doesn't need to change. This is the magic of Hotwire Native. So let's take a look at a real-world example. Here, I have a screenshot of the Ruby Friends app, an app that I built to help keep track of who I meet at conferences. And this is usually looking at it on Safari in responsive mode. So this is what the mobile web version would look like. Here's what that app looks like on iOS with Hotwire Native and Android. You can check this out at rubyfriends.app or download them from Google Play or the App Store. For the native apps, we have what we talked about earlier, the native navigation bar up at the top. We have the native title, the native 3 dots overflow button to show a drop-down menu. And down at the bottom, we have a native tab bar to switch between tabs and context. For those in the back, we have My Profile, My Friends, and Notifications down at the bottom. But that's the Chrome. That's lowercase c. That's the Chrome around it. The magic is inside, the web content. Nope. It's the same web content that we're rendering on the web. We have some differences here where we're hiding that navigation bar on the web because we already have a native one. But for the most part, we're sending the same exact, we can do that with CSS. So same HTML. This tiny native shell offers a lot of magic for both the developer experience and the end user. Here we have the second tab of the Ruby Friends app, a listing of friends. When I tap on a link, we get native transitions built by the OS. Under the hood, Hotwire Native is creating a Turbo.js custom adapter that hijacks that link click. And instead of doing an XHR like we do on the web, we're actually pushing a brand new view controller onto the stack using a native navigation controller, which means we get these beautiful animations on iOS, and not to mention these same animations but platform-specific on Android. Your users have come to expect these transitions, and they'll feel right at home on Hotwire Native apps because it's the same thing. The only difference is that the content is fully web. Along the bottom, we have our native tab bar, iOS and Android. These are first-party controls. They're not, it's not some JavaScript Frankenstein of React and rendering out custom things. No, these are UI tab bar controller on iOS and bottom navigation bar on Android, which means that they come with all the same features that your users are accustomed to, like having separate stacks for each one, and when you tap on one, it pushes the whole stack back to the beginning. They look like native controls and they feel like native controls because they are. And it also means a hidden benefit is that when a new version of iOS comes out or Android and the design paradigm changes, when would that ever happen? When would we get things like liquid glass? In like a couple days. So this is iOS 26. This is what it looked like on iOS 18. The code changes to make it look like this? Nothing. All we had to do was rebuild in Xcode 26 to get the new features, because we're just using first-party from Apple or Google controls. With React Native or other hybrid frameworks where they're building their own controls, it might take weeks or months or years to actually get something that looks and feels like liquid glass. OK, so we've built our MVP. We have our essentially like the smallest amount of work we could do to get something that looks good and submitted to the app stores. But you want to go deeper. You want to actually use the native integrations that are built in or that you want to build yourself. You want to level up with custom native integrations. Let's talk about 2 ways where we can integrate native code into our app. The first is with fully native screens. Here, we have 2 screens, one from the Hey email app and one that shows a full screen map from the app that you'll actually build in my book. These offer 2 different benefits. This home screen on the left means, because it's native, the next time the app is launched, it will load instantly. No network request required, because we can cache that data. We also get native look and feel and controls platform specific. If you slide across one of these, it'll slide off and go to the left, just like you would with any old iOS app. With the map, you avoid that awkward 2-finger scroll thing that you get on mobile web, and you get access to more robust APIs, like turn-by-turn directions or 3D rendering. Only possible on mobile apps. Native screens are perfect for your highest fidelity and performance screens. If you're building a game that you want to actually render out something complex, use this. If you're dealing with maps or native SDKs or your showstopper features, reserve these for the one or two things that set your app apart from the rest of the stuff in the App Store or on the web, because they incur the highest maintenance cost. Remember, you're stepping out of Hotwire Native world now. You're no longer rendering a web view. You're rendering native content. And with that comes all of the rigmarole of JSON endpoints and duplicated business logic and networking and all that's required. But let's see how it works. Let's take a high-level approach at building that map, but for Android. So we'll start off with a Google map. This is Kotlin. This is a Jetpack Compose composable function that renders out, well, a Google map. We'll wrap that in a map fragment that extends or inherits from Hotwire fragment, and that gets our Chrome. We now have our native back button, our native title up at the top, and our status bar at the time, and networking stuff. From there, we'll decorate this with a Hotwire destination deep link URI, a mouthful for saying an ID for this thing. This ID we'll use on the server. So this is a JSON response on our server that sets the path configuration for our apps. It's a way to remotely configure the behavior of our iOS and Android apps dynamically. So it takes an array of rules where we match URL patterns, URL paths, to properties. What this says is anytime a user clicks a link that ends in /map, $ for the regex, apply the Hotwire fragment map URI. Hotwire Native under the hood automatically sees that and doesn't display your web content. It displays this fragment for you. And now you're in native world to do whatever you want. The benefit of keeping this on your server is that one day you decide that you don't like the /map and you want to call it /directions. Well, you just change it on your server, and the next time the user launches the app, they'll get that change, and then they'll route anything ending in directions to the map fragment. Hotwire Native is responsible for downloading, caching, and applying all of these changes out of the box with one line of configuration. But like I said before, native screens offer the highest fidelity at the highest trade-off. So when the burden of a native screen is too much and you still want to take advantage of your web content but add some native stuff around it, we can reach for bridge components. We can add buttons to the top right of the screen in text or images, or maybe a full drop-down on Android. These bridge components are the Hotwire Native feature that I am most excited about. They're native sprinkles for your app. I like to think about them as stimulus, but for native code. The benefit being that they have access to the full underlying SDKs and APIs that are available on that platform. So let's take a look at the architecture of these. We'll start off with a plain old stimulus controller. Nothing new here. And when that data controller appears in the DOM, the connect method fires. Now, bridge components offer a third piece of this puzzle, the native side. This would be written in Swift for iOS or Kotlin for Android. When the stimulus controller wants to communicate to the native component, we fire this .send in JavaScript. Then the native component replies back with a primitive. The stimulus controller can say, hey, what is the user's heart rate right now? And the native component can do all of the authentication and authorization and API fetching to send the heart rate over as a number back to stimulus, where you can write it to the DOM or make a fetch request to pop it on your server and persist it. You're back in control on the web. Let's build one of these live. So we're going to build this add friend button, which you can find in the Ruby Friends app, but I think it's a plus sign now. And this button is a link to a new friend path. We'll start with the HTML. We have a add friend button that links to the new friend path, a link to. We'll add a data controller to that. Bridge dash dash button. The double dash is to namespace the controller under the bridge directory. We'll generate that controller through the stimulus generator. BinRails generates stimulus bridge slash button, which pops this button controller in the bridge subdirectory like I mentioned before. I like to keep all of my bridge components separate from my web components, my web controllers, because they serve a different purpose and it's easy to see them all in one spot. Opening up that file, we have our stimulus controller. Nothing about this is Hotwire Native or bridge component related yet. So let's replace this import statement and import it now from Hotwire Native bridge and replace controller with bridge component. This extends or inherits the controller we just had, which means we have access to all the underlying APIs of stimulus. Data, values, classes, we can use all of that here. But we also have some new stuff, like identifying this as the button component for native apps. And like I said earlier, we can pass messages along to the client by calling this.send. Here we're saying, send the connect message to the client. Pass along a little context. Here we're giving the title of the link that we just attached to the DOM. And finally, a callback. This callback is triggered when the client calls reply to. This code will be executed, which means that when we trigger this callback, the app will just click the add friend link and visit the new friend path. This could be a link, it could be a button, it could execute JavaScript. It's just clicking it under the hood. That wraps up part 2. Let's move on to the JavaScript, or the stimulus, excuse me. Let's move on to the iOS side in Swift, where we create a button component that inherits from bridge component. We'll identify that with the same button string that we had on stimulus, and we'll override the only function required on receive. This gets called every time this.send is fired from the web. Here, we'll extract that title that we passed along as context, as a string, and throw it into a UI bar button item. It's a button, but Apple doesn't call it a button, it calls it an item. It doesn't inherit from button, it's a whole other thing. But these things we can put on the top of the screen. We'll attach a callback to that, just like we did on the web. This gets fired when the user taps on the button to reply to the connect function, to the connect message, which will, in turn, click the HTML link. Finally, we'll throw it on the screen in the upper right via the navigation item. Once we build that, we get our add friend button up in the upper right of the My Friends screen or page. But the magic of bridge components isn't actually building them. It's their reusability. Once we have those 3 pieces built, we can start adding HTML markup to other screens, like this, and have that button appear on new screens. No native code changes would be required to add this button to a new screen. It means if you deploy your app with the native code included, you could add this button a week, 2 weeks, month later, and it will just start to appear for all of your users the next time they hit this page. No App Store review required either. Bridge components are truly build once, use everywhere, over and over again. But they aren't limited to little buttons in the upper right. No, not at all. Bridge components have immense power. We can create native drop-downs powered by UI menu on iOS. We can scan physical paper and use on-device ML to turn that into a PDF powered by Android. And then get that PDF in one file in our stimulus controller to then write to the DOM or send to the server. We can grab the user's notification token on iOS, write that to the server, and then start sending them push notifications through APNS. We can use the built-in barcode scanner on Android that automatically zooms in and adds that colored box around QR codes to show the user what they're scanning, and then dismisses and sends the URL to Stimulus. Or on iOS, we can create a secure app that when you put it in the background, it locks it and puts a white screen over all of the content until you unlock it with biometrics like Face ID or Touch ID. You could also get to the user's location, even in the background, with only one prompt instead of 3. All of these things are not only possible with mobile apps and not on the web, but they're abstracted with bridge components that you build it once at the bare minimum level, at the most abstracted level, and then you can use it anywhere else on your app. To get a better feel and to see what these really look like under the hood, you can check out bridgecomponents.dev. I've put together 16 of these that you can copy and paste into your iOS and Android apps, along with the stimulus controllers to go with it, along with full documentation for HTML about how to add those to your app. This is pretty powerful for Hotwire Native because this is the first time a component-like library has been released. And I'm really excited to see this move forward. So if you have any suggestions or want to submit a pull request, that's all welcome. OK. We've seen how it works. We've seen what it's good for. We've even seen kind of the underlying pinnings of it. Let's take a step back in time and talk about how we got here today. How did we end up at Hotwire Native? Zoop. Back in 2016, TurboLinks Native was officially launched by Sam Stevenson at his rather famous "I can't believe it's not native" talk at RailsConf Kansas City. He showed this diagram about how complex building for mobile with a JS front end, with a Rails API backend could be. And then blew it all away by building probably the first ever live demo of TurboLinks Native, turning Basecamp into an iOS app live on stage. From there, we've gotten 2 major jumps. One in 2020 with the rebrand to Turbo Native, which was a rebrand. No new features, except that TurboLinks JS became Turbo.js, so Turbo Native wanted to follow along. But it was still the same clunky, very verbose API. You had to do a lot of boilerplate to get everything working. It scared a lot of Rails developers away, and rightfully so, of doing native development. But in 2024, we saw the first release of Hotwire Native. Jay from 37 Signals announced this right before Rails World last year. And this brought mobile app development to Rails developer in an accessible way for the first time ever. What took hundreds of lines of code to build a real working iOS or Android app was now down to like 12 or 15. As an example, here's what it used to take to build a Turbo Native app on iOS. We'd have our scene delegate assign a window, pop it out with a custom Turbo navigation controller with subclass navigation controller. On the load, we would hit the local host, make sure to visit the visit options, have 2 sessions, make sure we popped it on visit, and then make sure that we handled errors, and of course, if the session crashed, we'd reload it. Easy. But not attainable. Also, all of this is boilerplate. If I've built 50 Turbo Native apps, 48 of them had this exact same code in it. There's no need for everyone to be writing this over and over again. With Hotwire Native, that turned into this. This is now all you need to get started on iOS to build a Hotwire Native app. 11 lines of code, which you could even shorten if you put the whole private navigator thing on 1 line. But this means that we can now expect Rails developers to build mobile apps because the Swift required and the Android required, the Kotlin, is no longer overwhelming. Hell, it even looks pretty. Hotwire Native also gave us new documentation. For the first time, Hotwire Native is a first-class property or entity in the Hotwire namespace. We now have Turbo and Stimulus and now Native up at the top. This doc site is brand new, custom branding, open source, and also includes guides specific to iOS and Android on how to get started. If you leave today and you're like, where do I go next? native.hotwire.dev. Check out the iOS and Android Getting Started guide, and that will walk you through taking your Rails server to iOS and Android and really seeing what Hotwire Native can do in 12 lines of code. We also introduced new demo apps. More powerful than ever, these demo apps include native tab bars along the bottom, which are now included in Hotwire Native 1.2. They handle 3 different bridge components that you could copy-paste into your app if you wanted. They also show an example of how to go from native screens and back again to the web context, giving you the full picture of how Hotwire Native works. These hit a demo server that lives forever at a URL. So when you launch this, you can hit that demo server and not have to worry about running anything locally. But before, this demo server was written in Express.js, which created some confusion. How do we redirect? Where's the Rails code? What about authentication? Well, with our latest release, we've now migrated that demo server to be a Rails server, which means that you can build out complex interactions like this. And all you need on your server is redirect to. So what's going on here is that we're presenting a form. I'll wait till it starts. We click our link. It presents from the bottom as a modal. We fill in our information. We have a bridge component in the upper right showing a native submit button. That dismisses the screen and pushes a new screen on the stack, and we get our flash message for free. Hotwire Native is now integrated into Rails in a way where you don't need to do custom routing on the server just to get it to work. Simple redirect tos, flash messages, modals, they all work out of the box. And all of the different scenarios that are now handled, all 15 and more, because I couldn't fit them on the slide, are now handled out of the box on Hotwire Native. Which means that you don't have to worry about if you're going from a modal to a non-modal to a stack to a pop to a replace. You just pass along the context, and Hotwire Native will take care of it for you. We're also getting a bunch of new features in Hotwire Native 1.3. Included in that are custom animation to fade when the screen replaces itself. Tab bars that load lazily instead of loading them all the time, potentially overloading your server. Customizable error handling with native views with just one callback. There's about 6 PRs open on the Hotwire Native iOS repo. Take a look if you want to see more. It might not make it to 1.3, but what I am most excited about is offline caching. This is easily the single most biggest blocker I have when working with clients. They are all in on Hotwire Native. They cannot wait to get started. And then we get to signing the contract, and you're like, great, how do we do offline mode? And I have nothing. Offline caching will give us access on Turbo.js, where when we visit a page, it will store in our cache using a PWA-like manifest. And then when we visit that page, it will load the cached copy if we lose internet access. We'll be able to configure it with this, taking advantage of a service worker. And to get it working for Hotwire Native apps, native true. So very excited here. Rosa is working on this in PR 1427. But more importantly, she's speaking tomorrow at her talk, bringing offline mode to Hotwire with service workers at 1:45 tomorrow. I'll definitely be there, and I encourage you to as well. So we've seen how it works. We've seen all the fun stuff that's coming, all the stuff that how we got here. But who's having success with it? Who is taking advantage of Hotwire Native and seeing real business benefits from it? Let's talk about a few folks in the community who are using Hotwire Native to their advantage. First up, we have Adam from Sleep HQ. He's built an iOS app with Hotwire Native that optimizes CPAP therapy for folks who suffer with sleep apnea. This iOS app integrates with custom Bluetooth medical devices and also has an integration for Apple Health and Apple Watch. He's combining all of this data that he could only get from a native app and presenting it in beautiful charts and graphs for the user. Charts and graphs that are rendered on the web, where it's easier to render those things. ChartKick, ChartJS. Only native apps have access to these integrations. And if he had to build the whole thing in React Native or fully native, he would lose all of the feature parity of the hundreds of models and controllers that he would get when using Hotwire Native. Native sprinkles only when needed. We have 37 signals, perhaps the poster child for Hotwire Native with their 3 apps, Basecamp, Hey Email, and Hey Calendar. If you're looking for a really good example of what Hotwire Native is and can do, check out any one of these 3 apps. They are pushing them to the limits with native home screens, native interactions, and already using a bit of offline caching. But why I bring them up is that they are using these to scale to millions of paying customers. These are their flagship apps. They chose to use Hotwire Native again for Hey Email and Hey Calendar when it came out. They didn't migrate off of it. It's not a pet project. Hotwire Native is scalable to millions of dollars of revenue and beyond. Next up, we have Nadia from the Story Graph. She's built a Goodreads competitor that has access to a bunch of native features like push notifications, native tab bars, and even in-app purchases, which are notoriously the most difficult to build on iOS and Android apps, Hotwire Native aside. She's scaled this to 4 million registered users. But the most exciting part is that she's doing it as a one-woman dev team. Hotwire Native unlocks mobile apps even for the smallest of dev teams, all the way down to a single solo developer. I talked about Ruby Friends a little bit earlier. On the way home from RailsConf, I actually built the prototype for this. Way to keep in touch with friends that you meet at conferences, scanning badges and stuff like that. Integrated a bunch of native features in the iOS and Android apps, like push notifications, QR code scanning, and NFC reading and writing, all with, of course, bridge components, all also available in that bridgecomponents.dev library I was talking about. But why I'm talking about this is that this went from idea to in the App Store in just 2 weeks. Hotwire Native is finally bringing back the speed of web development that we're used to mobile apps. Apps that used to take weeks or months can now take days if you're building with Hotwire Native and just reusing your mobile web screens. And even going beyond MVPs and adding native features with pre-made bridge components. These are some other apps built with Hotwire Native by the community, available in either Google Play or the App Store. Some developers of these apps are in the audience, I see. With Rails, the web was just the beginning. With Hotwire Native, mobile apps are now. With Hotwire Native, we can launch instantly. Less than 20 lines of Swift or Kotlin to take our Rails app from the browser to the app stores. With Hotwire Native, we can keep writing Rails. We don't need to become expert mobile app developers. We can ignore the minutia of iOS and Android app development and just stay in our comfort zone. With Hotwire Native, we can deploy when we want, ship a feature, and instantly see it accessible across all 3 platforms. No one's stopping us from iterating daily or hourly or every minute, because we can ship without gatekeepers. No waiting for review, no mystery rejections, just our web content in mobile Chrome. With Hotwire Native, we can finally own the full stack. It's quick enough for a tiny team or even a solo developer to get started, but robust and extensible enough to scale to apps with millions of dollars of revenue. Now get out there and ship. But before you do, if you need a little bit of help, this is my book. And for everyone in the audience today, a tiny 50% off discount with Rails World Joe. That cut off. That's supposed to say Rails World Joe. And yeah, come talk to me if you ever want to talk about Hotwire Native. Thank you so much. Thank you to the Rails Foundation. It's been a pleasure.